Hello everyone, and welcome to our fourth Amazon DocumentDB with Mongo compatibility focus day of 2023. My name is Jason Plank, and I'm a senior go-to-market specialist on the DocumentDB service team. And my partner in crime here, Guru, will also help walk us through our overall agenda, which will include the topic of cost optimization best practices. Little introduction of myself. I've been in the industry for about 20 years and have held various roles such as product management leader, development leader, and obviously my role at AWS as a GTM specialist. When we look at our agenda for today's sessions, we're going to start off with why document databases. Then we're going to talk about a little bit about an introduction to DocumentDB. Then we're going to go into a well-architected lens review, which is one of our popular programs that we offer to our customers. Then we'll walk through cluster sizing and configuration. And then we'll finalize with workload optimizations and then ultimately metrics to monitor for cost optimization. The first stage of kind of looking at why document databases is understanding the landscape of services that AWS offers. We do offer a very broad set of database and analytics services, and today we're going to focus on database services, specifically Amazon DocumentDB. But as you can see, for customers wanting to move away from self-managing Oracle, SQL Server, MySQL, Postgres, and MariaDB databases, AWS offers RDS and Amazon Aurora. Then in the non-relational section, for those customers that want to move away from self-managed non-relational document and key value stores such as MongoDB, Redis, and Memcached, AWS offers DynamoDB, DocumentDB, and Elasticache in that area. And as you can see, we do have a wide array. If you're looking for a wide column solution, we have key spaces. A graph solution, we have Neptune. But you can see at AWS, we're really focused on the right tool to solve the job and to help our customers meet their business outcomes. When we look at why document databases, it starts with JSON. DocumentDB, as an example, stores data in a JSON-like format, which is flexibly structured. This structure maps naturally to how we think about modeling data in our applications. We typically don't model data in tabular formats in our heads. We're thinking about groups of things instead. In addition, one of the popular reasons is for flexible schemas and indexes. Dynamic schemas can change depending on ultimately your data needs and access patterns, and there's no need to design rigid, complicated schemas. In terms of indexes can be created and dropped in on demand to meet ever-changing application requirements or query patterns, and can be declared on any field within your documents, including fields nested within arrays. Another reason is ad hoc query capabilities. So in this area, if you want to retrieve special fields and values, or even regular expression queries, because DocumentDB uses a JSON kind of query language, it's very easy to learn, very easy to pick up. In terms of Amazon DocumentDB use cases, they are far and wide and many, given that DocumentDB offers both flexible schemas and extensive query capabilities. The document model works well with use cases that require complex documents that are dynamic and may require ad hoc querying, indexing, and aggregations. A popular use case is content management, and if you think about it, much of the content that we read today, from news articles to blogs to recipes to patient records, all of that data lends itself really well to a document model since it's dynamic and changing. Mobile and web. Well, mobile is a gimme. As you know, JSON is heavily used in mobile development, so it's very, very easy to store that data that you're collecting going back and forth between devices. Catalogs. We have customers that want to be able to record the output of machine learning experiments, maybe inventory descriptions, pharmaceutical trials. We really see a broad set of customers that use documents for these use cases. Gaming, not just to store user profiles, but game management, matchmaking, that type of thing. Personalization is a common use case. We see customers customize offers based on transaction history or financial data to improve ultimately user experiences. The real I would say the real driver here is any application that requires flexible schemas or indexes or ad hoc query capabilities are a real slam dunk for DocumentDB. In terms of customers, Amazon DocumentDB is being used today by a wide variety of customers, from long-standing global enterprises like Capital One to digital natives like Rappi and Zulily to game publishers like Habi. In addition, several products that Amazon customers use, such as Fulfilled by Amazon, the FBA experience on Amazon.com, are powered by Amazon DocumentDB. We have customers in virtually every industry, from financial services to retail, from gaming to manufacturing, from media and entertainment to publishing, and more. We definitely welcome you to explore our customer page, where you can hear directly from DocumentDB users on why they choose DocumentDB and how it has positively impacted their business. The next thing I'll just talk about is kind of a brief intro into what is DocumentDB. So it is a managed service, a managed database service, ultimately to manage and store native JSON documents. It's fast and scalable, as we've decoupled compute and storage to support independent scaling of both of these. We can scale to millions of reads and writes at this stage using read replicas for instance-based clusters, and then with elastic clusters, we're able to scale writes and reads we're able to scale over 1 million of writes and reads and up to a petabyte of storage with elastic clusters. It's fully managed in that we take care of patching, bootstrapping any type of systems, and ultimately day-to-day management is taken over by AWS. Ultimately, that improves productivity and lowers the total cost of ownership. And really the main driver to that is that it will remove the undifferentiated heavy lifting that operators would typically do. It's enterprise ready, and it's highly available in that you can achieve 4 nines of an SLA for your database service, and also because of our underlying storage architecture, in that we maintain 5 copies of your storage, we are also very durable. We also have global clusters to provide local reads and disaster recovery from region-wide outages, and we believe in security first. So we have built-in security best practices with encryption in transit, and encryption at rest. Natively, we are a VPC-only service. We are a MongoDB compatible service, so if you're using the MongoDB API, we support hundreds of APIs, operators, and data types. One point that I'll make is that we are not a drop-in replacement for Mongo, so it's very important that you leverage some of the tools that we've built. We have a compatibility tool on our GitHub that's managed by our specialist SAs. That's definitely something you can use to view your log files and ultimately report back if what you're doing in Mongo today is supported on DocumentDB. Because we are using MongoDB APIs, you can use a lot of the same drivers and tools that you already use today with very little change. And that's, again, we have several other focus days. There's the Introduction to DocumentDB Focus Day, which was our first one of 2023. I would definitely recommend you go look through that, as it talks about the architecture and gives a real deep service overview. In terms of innovation in Amazon DocumentDB, that's something we always like to touch on. We did launch DocumentDB in 2019, and in the last 4 years, we've continued to innovate on behalf of our customers. Most recently, some of the highlights are that we've launched DocumentDB 5.0. In that, we support the underlying MongoDB 5.0 wire protocol. We also increased our cluster storage size from 64 TB to 128 TB, and we also now have support for client-side field-level encryption. In addition, we launched Lambda Event Source Mapping, which will allow DocumentDB. What we can do is we can trigger Lambda functions now via change streams. So that's a really cool feature and functionality our customers are asking for. Another big release was, as I mentioned, Elastic Clusters, which allows you to support up to millions of writes and reads and up to petabytes of storage to really increase your scale. And we have customers looking to adopt that new scalable solution that we've just recently launched. And in terms of visibility, performance insights, the preview that we're doing, as well as DML auditing, provide customers a lot of visibility into their workloads and their queries. Another big, a big feature that we launched recently was decimal 128 support for those really strong mathematical type workloads. I don't cover everything in the slide, but really the message that we want to drive home is that we are continuing to deliver on behalf of our customers, and we definitely continue to work backwards from our customers to ultimately deliver business value in terms of our technology solutions. At this stage, I'm going to go ahead and pass the mic over to Guru, and Guru will start walking us through the well-architected lens for Amazon DocumentDB.
Hey, thank you, Jason. I'll begin by giving a brief introduction to the well-architected framework. Then we will dive deep into cost optimization. What is AWS well-architected framework? The well-architected framework is a collection of best practices gathered from years of experience of solution architects at AWS and developed to help our customers to build a secure, high-performing, resilient, efficient application infrastructure in the cloud. It has been used in tens of thousands of reviews conducted by AWS Solution Architecture team and provides guidance to help implement designs that scale with application needs over time. A well-architected review looks at a workload from a general technology perspective, which means it cannot provide workload-specific advice. Well-architected lens for DocumentDB provides best practices, design principles, and questions to assess and review DocumentDB workload. This provides a focused review for DocumentDB workloads. Well-architected lens defines the process and enables us to ensure that customers are successful and help customers to identify opportunities to optimize their workload before they encounter any pain points due to not following best practices. Well-architected lens for DocumentDB is made up of 5 pillars. Each one has questions and best practices to support your workloads. The 5 pillars are operational excellence, security, reliability, performance efficiency, and cost optimization. So when you incorporate these pillars, it will help you produce stable and efficient systems. Our discussion today will focus on cost optimization pillar. The cost optimization pillar focuses on avoiding unnecessary costs. Key topics include understanding and controlling where money is being spent, selecting the most appropriate and right number of resource types, analyzing spend over time, and scaling to meet business needs without overspending. Before moving on to the cost optimization pillar, let's take a closer look at Amazon DocumentDB's pricing model. DocumentDB operates on a pay-as-you-go pricing model. That means you pay only for the service that you use for as long as you use and without requiring long-term contracts or complex licensing commitments. You only pay for the service you consume, and once you stop using them, there are no additional costs or termination fees. And DocumentDB is priced on 4 pricing dimensions. First dimension is based on what instance you use. That varies by instance size and number of instances in the cluster. For example, T4G medium costs you 7.566 cents an hour. If you require more read capacity, you can mix and match different instance sizes. So pricing is based on the cluster size, instance class, and number of instances within the cluster. IO is the second dimension and is charged at 20 cents per million IO operations. Any operation between compute and storage will result in an I/O operation. For read operations, documents up to 8 KB in size result in one I/O operation. And for write operations, documents up to 4 KB in size results in one I/O operation. The third dimension is storage and is charged at 10 cents per GB per month. You don't need to provision storage in advance. You simply pay for the storage that your cluster uses. The fourth pricing dimension is backup, and the cost of the initial data load is free, followed by 2 cents per GB for incremental increase in storage. Basically, 100% of your storage data backed up for free. So if you have 10 terabyte of data, you can back up all 10 terabyte for free. Automatic backups are enabled by default. So by default, it is enabled for 1 day, but you can increase that all the way up to 35 days. Let's look at some of the contributing factors for each of these pricing dimensions more in detail. I'll start with first pricing dimension, instance optimization or cluster sizing. When size is right, you will be able to achieve optimal performance and cost while using DocumentDB. In this section, we'll discuss about best practices to size your DocumentDB cluster. So the vCPU, or the compute capacity, and the memory of the instance determines performance. There are many instance types available in DocumentDB, ranging from 2 vCPU and 4 GB of memory all the way up to 96 vCPU and 768 GB of memory. And the best practice is to ensure both indexes and frequently accessed data fit in memory. Also keep in mind that the amount of cache that is available for your working set, that's your frequently accessed data and index, is 2/3 of the available memory of the instance. So if you take an example of R6G.12x large, a 384 gigabyte machine, only 256 gigabyte is available for your working set. And the rest 1/3 is used by the operating system and database processes. So when it comes to selecting an instance, the best practice is to make sure the index and working set fit in memory. And when it comes to the number of instances in a cluster, it is determined by your availability target. So if your availability target is just 2 nines, you can be happy with just one instance. Again, the recovery time in this case is about 8 to 10 minutes. Because if that instance goes down for any reason, it takes around 8 to 10 minutes for a new instance to be provisioned and be available. And usually this is a good setup for a dev or test kind of an environment. But in production, you may say, hi, I want 3 nines of availability. So you can go with 2 instances where you will have one primary instance and a read replica distributed across 2 different availability zones. And in this case, if the primary goes down, the replica will be promoted to primary in less than 30 seconds. So that's your recovery time. And if you want 4 nines of availability, then you can go up to 3 instances. With 3 instances, you got 4 nines of availability. Basically, your configuration is going to be one primary and 2 read replicas distributed across 3 different availability zones. Again, the recovery time is going to be same, less than 30 seconds. Now, if you add more instances, your availability target is not going to increase. So why do you add more instances then? Generally, you would do that if you want support more read throughput. By adding additional nodes, you can increase read capacity. For example, today I'm supporting 200,000 reads per second. I want to increase it to 400 reads per second. Then you may probably want to add more instances if you are already running low on available compute and memory in the existing replicas. To summarize, the best practice is to select an instance where the index and frequently accessed data fit in memory. How many of those instances is determined by your availability target. Example, dev test, you can go with 1 instance, but for production, you may have to consider 2 or 3 instances based on your availability target. Another instance cost optimization best practice is to start and stop your DocumentDB clusters. This is a good option for dev and test clusters as you can turn them off over the weekend or non-operating hours. To stop DocumentDB cluster, you can select a cluster and choose stop from the actions menu. Stopping a cluster will avoid incurring instance charges. The storage cost will continue as the data is available in the cluster. Since there is no incremental increase in storage volume, as there is no primary instance to accept any writes, backup costs don't increase as well. Stop clusters restart automatically once in 7 days to apply maintenance patches. Next pricing dimension is IOPS or IO operations. IO operations is a dynamic variable in pricing. Let's dive deep to see what are the sources and how we can optimize IOPS cost. Any operation between compute instance and storage layer results in IO operations. Each document read or write can take more than one physical IO depending on the document size. The source for this IO includes write to or reads from storage layer, index scans, index creates and updates, soft deletes due to MVCC architecture. All of this can contribute for your IO operations. It's a good practice to estimate IO usage by benchmarking and observing IO's build and monitor IOPS usage in the billing dashboard. Let's dive deep on IO cost optimization. IO optimization is carried out from three main angles: optimizing indexes and queries, sizing the database cluster appropriately, and designing the best schema and retention techniques. Let's explore each of these topics in detail. DocumentDB doesn't currently support compression for indexes, so be frugal when creating indexes and remove unused indexes and optimize indexes. For example, one compound index is smaller than multiple singleton indexes. You can run the following aggregation query to identify the unused indexes. Drop these unused indexes and that will free up your instance memory to cache other indexes and working set. TTL indexes incur IO cost when deleting data. If possible, use rolling collections to minimize IO cost. Create new collections at a desired interval, for example, one collection per day, and write all your records into them. Drop the whole collection when expired or beyond retention period. Instead of deleting the documents on daily basis, you drop the entire day's collection at once. There is no IO cost for dropping a collection. The drawback of this strategy is that if it spans to numerous collections, you will need to submit separate queries to each one. But this approach saves IOPS and is efficient with respect to performance as well. So again, you'll have to make that trade-off. It's efficient with respect to IOPS, but with performance, you will probably have to do joins. So you have to evaluate it case by case and take a decision accordingly. And then optimize your queries that are not performing at desired SLAs. Avoid using collection scan or union scan. DocumentDB supports covered queries or IX scan only. These are queries that will leverage the index for supporting to query. And if you use index scan or index only scan, you will perform less scan and hence less IO operations or less IO cost. So as a best practice, ensure that your queries are using appropriate index, else you might end up reading a lot of documents from the storage layer, incurring significant IO cost and performance impact. Also create indexes on fields that are highly cardinal as it ensures high selectivity. Ideally, we would want the selectivity to be at 1% of the documents. When using sort in query, use the sort key as index suffix. This will minimize the scans and number of documents read from storage layer or disk, reducing overall IO operation cost. To summarize, delete unused indexes to free up memory for working set. Use rolling collection to reduce IO operation required for deleting the expired records. Avoid collection scans and define indexes on highly cardinal fields to ensure high selectivity that results in less IOPS or less reads from storage layer. So now it's demo time. In this demo, I'll show you how you can use the explain plan, and I'll also show how you can tune queries by creating appropriate indexes. Let's switch to the console now.
I am on DocumentDB console now. In this demo, I will show you how to use the explain plan and how to tune your queries by building the right indexes. I have a couple of DocumentDB clusters here. Let's select demo docdb. To connect to this cluster, I will use Mongo shell. The connection string required for connecting from Mongo shell can be copied from Connectivity and Security tab. Now I am switching to a terminal on my Cloud9 Web IDE and connecting to DocumentDB cluster. Here, I'll enter show DBs to list all the databases. And as you can see, I have a couple of databases here. So I'm going to use the airports database for this demo. And I'll type show collections to list all the collections in this database. As you can see, I have one collection called delay_monthly. Let's look at one sample document. This document has airport code, year, month, and delayed flights information. This collection stores all the delays by airlines for US airports. Let's run a query on this collection with airport code as JFK for the month of June sorted by year. Basically, I am trying to get all the airline delays for JFK for the month of June sorted by year. I'm running this query with explain plan and I'm passing this execution stats as parameter. So if you look at this explain plan, it performs a collection scan because I don't have any index on these attributes. And it takes around 265 milliseconds as overall execution time. Of the entire execution time, it has taken 262 milliseconds for collection scan alone. This also increases I/O cost when you have large number of documents in your collection. So how can I optimize this query? Now I know that the bottleneck is because of the collection scan. So what I'm going to do is I am creating an index on the attributes used in our query with sort attribute as suffix. So you need to find the right attribute based on your query and create index on them. So if you look into our query, we are querying on airport code, month, and sorted by year attributes. I'm adding year as my suffix and the other attributes airport code and month as prefix for our index. I'm going to create index. Now this create index process is creating index for around 200,000 documents in our collection. And our index creation is completed now. I am going to run the same query again with the explain plan which earlier took about 264 milliseconds. Now you can see AX scan or an index scan is happening and the time from 264 milliseconds came down to less than 2 milliseconds and the overall time for input stage has reduced from 262 milliseconds to 1.209 milliseconds. So that's a significant improvement in performance. So again, this is a very simple example on how you can perform query tuning and use appropriate index strategy to optimize your queries for performance and to optimize cost. As with indexes, you will be reading less document from storage layer. So let's go back to the presentation. As discussed earlier, in the cluster sizing, ensure that indexes fit in memory. You can use index stats to determine index size and determine the instance size that will fit index in memory. Monitor index buffer cache ratio to check if the indexes are scanned from memory or disk. Also keep in mind, only 2/3 of memory is available to cache your working set. If your working set is larger than the available memory in the instance, then you incur additional I/O cost for reading indexes and data from the storage layer. So, as a best practice, always make sure both your index and frequently accessed data fit into memory so that you don't have to read from the storage layer. And to remind you, instance count is determined by your availability target. DocumentDB is ideal for OLTP workloads. It's a best practice to define retention period and delete older documents. It's a good practice to limit indexes to 5 or less per collection. Otherwise, your memory requirement may increase to accommodate all the indexes. Though the per collection limit is 32 terabyte, it is recommended to keep the per collection storage volume at around 5 terabyte for efficient management of data and indexes. If the collection grows unbounded and the reads and updates are always to most recent documents, then using smaller collections by moving older data to different collection will help maintain recent indexes in memory and also avoid updates to large number of documents and thus save I/O operation cost. Also, storing infrequent accessed fields in a separate document will help to reduce I/O cost and improve performance as DocumentDB performs operations at the document level and not at the field level. Along the same lines, separating mutable and immutable parts of the documents will help with performance and I/O optimization, as updates will happen to a smaller mutable document rather than a large document. From write access pattern perspective, model documents so that you can avoid frequent updates to same document. If you are expecting hundreds of updates per second or more to the same document, I would recommend you to benchmark performance because DocumentDB uses a write quorum of 4, which may limit concurrency for frequent updates. So now it's demo time again. So in this demo, I'll show how you can save cost by separating mutable and immutable objects. Let's switch to DocumentDB console again. For this demo, we will switch to a different database. Let me list all the databases again. I am going to use movies database for this demo. And I'll type show collections to list all the collections in this database. We only have one collection here by name movie details. Let's look at the stats for this collection. So I'll type db.movies_details.stats. So you can see this collection has around 137,000 documents with an average document size of 11 KB. Let's look at one sample document. I already extracted one sample document in a JSON file. This document has details about a movie with title Once Upon a Time in the West, released in the year 1968. This has other details like runtime, countries the movie is released, genre, director, writers, cast, and rating from IMDb, Rotten Tomatoes, and Metacritic. And also has a large array object with reviews from various critics from different sources. As you can see, this is a large object of size around 11 KB. As if you have to update only small portion of this document, it would be better to split the document into mutable and immutable parts. Again, you take this decision based on your average document size and your access pattern. As a reminder, write I/O operations are counted in 4 KB units, and if your average document size is more than 4 KB and you are updating a small portion of that document, then consider separating mutable and immutable objects. In our hypothetical scenario, to demonstrate the benefit, assume we want to increment the IMDb votes and Rotten Tomato reviews by 1. We'll be updating all the documents in the collection by incrementing the IMDb votes and Rotten Tomato reviews by 1. Let's see the result in action. I'm switching back to DocumentDB console. So I have two clusters here, demo.db and demo.db2. In demo.db, I have one collection with large object, and in the second cluster, I have split the mutable and immutable parts of the document into 2 different collections. So switching back to Cloud9, so basically this entire reviews embedded array object has been moved to another collection in the second cluster. As we already reviewed, average document size is around 11 KB in the first cluster. So now review the stats for the split collections in the second cluster. So let me copy the connection string for the second cluster. I'll select demo docdb2 and copy the connection string from the connection and security tab. Let's switch back to Cloud9 environment and open a terminal. Let's connect to the second cluster. And this time I will use movies database. I'll type show collections. Here you can see we have two collections. First one with movie data except the reviews array, and the second collection with only reviews embedded object. Let's check the stats for these two collections. db.movie_details.stats. Now the average document size is around 937 bytes for the mutable objects. So we'll also look into the other collection. So db.movies_reviews.stats. And for the second collection, which is immutable objects with all the reviews, average document size here is around 10 KB now. So let's run the update operation on both the clusters. Here I am reading all the documents from movie_details object and incrementing the IMDb odds and tomato.reviews by 1. I'll run the same query on the other cluster as well. Let's review the I/O consumption on the CloudWatch logs. So this will take a couple of minutes before the volume write IOPS metric appear in the CloudWatch matrix. So I have pre-created a dashboard for our two clusters for volume write operations. Let's go and open the CloudWatch console. Type CloudWatch. And then select and open CloudWatch in another window. So let's choose our custom dashboard. So volume write IOPS count under dashboard section. Here you can see our first cluster is consuming most of the I/O operations. In fact, 94% of the total I/O operations. Whereas our second cluster is consuming only 6%, that's around 29,000 I/O operations. And our first cluster is consuming around 463,000 I/O operations. In the second graph, you can also notice that the I/O operations consumed by first cluster is much higher than the second cluster. Thus, you can save cost by separating mutable and immutable objects when your average document size is more than 4 KB. Okay, let's switch back to our presentation. Let's look at optimizing third and fourth pricing dimensions, that is storage and backup. For optimizing your storage and backup cost, understand what is your organization recovery point objectives are. That will help you with determining your data retention policy. The amount of backup storage used depends primarily on the data change rate, how many snapshots you create, how long automated backups and snapshots are retained for. Carefully evaluate the use of automated backups and manual snapshots in the context of your data retention policy and your business continuity and disaster recovery requirements for each individual workloads. Verify that the backup retention period for automated backups are configured for each cluster that matches the intended workload and your retention policies. If your data change rate is low and you need to retain backups for a period of 35 days or less, it may be more cost effective to extend the backup retention period rather than using a shorter retention period and leveraging manual snapshots. Point to remember here is there is no additional charge for backup storage of up to 100% of your total DocumentDB database storage. For example, if you have a DocumentDB cluster with 300 GB of consumed database storage, we provide up to 300 GB per month of backup storage at no additional cost. So backup storage beyond this amount and backup stored after your cluster is terminated is charged based on the backup storage cost. So it's always recommended to remove all the unused backups and old backups. So basically review all your manual snapshots regularly and remove them beyond retention periods. Also note that deleting a DocumentDB cluster will not automatically delete the manual backups. You have to delete them manually. To summarize, make sure you set backup retention period based on your organization backup policy and delete the older manual backups post retention period. Let's examine how we keep track of our DocumentDB spend. There are many tools and services available within AWS to track your DocumentDB cost. You can track your DocumentDB usage using various CloudWatch metrics, use cost allocation tags while investigating which DocumentDB cluster or environment are contributing to your overall DocumentDB spend. And use AWS Cost Explorer or AWS Cost and Usage Report to drill down on exact cost contributors to your cluster. It's a best practice to create billing alarms. Set two alarms, one at 50% of your estimated spend and other one at 75% of your estimated spend. This will help you to validate if your estimated bill is close to the actual. For example, if you see that alarm goes off like a 50% alarm, let's say you expected $10,000 as a bill and you expect it to hit 50% of the bill in the middle of the month. But if it goes way sooner, you know something is wrong. So you can be proactive and go and do some research to see what is causing this usage to spike. And if it is IOPS, let's see how we can tune the IOPS. Second, use cost allocation tags to get cluster level visibility on billing. For example, what determines how much is spent on dev clusters versus test cluster versus production cluster. To figure out which of your DocumentDB cluster is contributing most of the cost in your billing dashboard, we will have to use the Cost Explorer. AWS Cost Explorer helps you to monitor, understand, and manage your AWS cost. This is where you can slice and dice the various AWS cost components. Here on this slide, you can see that the greatest contributor to my bill was storage IO from March 4th till March 20th, marked in green, right? So we did few optimization and post that greatest contributor is instance usage, marked in purple, and IO cost is significantly reduced. So Cost Explorer helps you to monitor and slice the cost at each component level so that you can identify and optimize your usage. Let's look at how we can create cost allocation tags, activate them, and explore using Cost Explorer. First, you can add tags to your existing or new DocumentDB clusters from the AWS console or from SDK by adding a tag, key, and value for the same. In this example, you can see I added a couple of tags. First one with key as environment and the value as prod, indicating that this is my production database. And second tag is to identify that this cluster belongs to Customer 360 application. Best practice is to tag all your resources like DB clusters, your database instances, and snapshots for cost tracking. And don't include sensitive info on your tags. These can be read by people with access to tags or billing. Once you have tagged your resources, you will have to enable these tags in the cost allocation tag section of the billing dashboard. This is a snippet from my billing dashboard. And after clicking on cost allocation tag on the left navigation pane, you will get the option to activate the tags you created for your DocumentDB resources. Once you have completed this step, the tagging information will start flowing to the billing items and then to the AWS Cost Explorer and also to AWS Cost and Usage Reports. In this slide, you can see how you can use the AWS Cost Explorer tool to monitor your spend. This snippet shows my DocumentDB cost on tagged environment in US East region for last 2 days. The AWS Cost and Usage Report contains the most comprehensive set of cost and usage data available. You can use cost and usage reports to publish your AWS billing reports that break down your cost by hour, day, month, service, or service resources to an Amazon S3 bucket you own. In this screen, you can see I have created a report with the specifications entered on the left-hand side. You have a choice of integrating this cost and usage report with three different AWS services like Amazon Athena, Amazon Redshift, or Amazon QuickSight for analytical purpose. In this example, I have chosen Amazon Athena. After you integrate this report with Athena, you can analyze the data on Athena as shown on the right-hand side of the screen. As mentioned earlier, all updates are returned to the distributed storage volume. Write IO operations are counted in 4 KB units and read IO operations are counted in 8 KB units when it is read from the storage. Ideally, most of your reads should be handled by the buffer cache or memory on the compute instance. If the information is not present in the buffer cache, then it will be read from the distributed storage volume, incurring additional read IO operation and associated IO cost. Volume write IOPS and volume read IOPS are a total count of billable IO operations for all instances in the cluster reported in 5-minute interval. Write IOPS and read IOPS are instance level metrics that show average instance operations per second rather than a total count. Note that you are only billed for the number of operations shown in volume write IOPS and volume read IOPS metrics. You should use these metrics to validate your benchmark testing and optimize your access pattern or instance type. If you have a very high IO bill and if you see a spike in volume read IOPS, go check your buffer cache hit ratio. This may be very low and most of the data is being read from the storage layer and not from the memory. As discussed earlier, DocumentDB utilizes approximately 2/3 of the memory on the compute instance for the buffer cache. The buffer cache caches frequently accessed data and index information. And the more you can cache, the better the performance will be and less the IO cost. Buffer cache hit ratio is a percentage of requests that are served by the buffer cache. An index buffer cache hit ratio is a percentage of index requests that are served by the buffer cache. Both these values should be as high as possible, since reading from memory is faster and more than reading from the storage volume. Reading from storage volume will incur additional IO cost. You can monitor your compute consumption of your DocumentDB cluster by matching up to two CloudWatch metrics like CPU utilization and freeable memory. Over here, we can see that CPU utilization started to increase from around 21 UTC, and you can notice there is a drop in freeable memory during the same span. This indicates that the workload running on this cluster is compute intensive. If this is the trend with your workload over a long period of time, probably more than a couple of weeks, then you can think of either query tuning or consider scaling up your instance size. These are the overall threshold that we suggest you keep for your clusters. You want your cache hit ratio as high as possible, probably over 95%. Just note, you will see occasional dips, such as in write heavy operation. So occasional dips is fine, but a consistent dip is not good. Freeable memory and CPU utilization should be looked at just like at any other EC2 instance. You don't want a free memory to drop continuously. Again, occasional drop is fine. And you don't want sustained high usage of CPU as well. If your CPU utilization is consistently above the threshold, then consider query tuning or scaling up your instance size. For storage and backup, these are the metrics we recommend monitoring. To optimize backup storage cost, use metrics like snapshot storage used, backup retention period storage used, and total backup storage used. Recheck your backup retention policy and make sure you do not store backup unnecessarily for longer period of time than you actually need. Higher retention period will increase your backup costs. As mentioned earlier, be careful on storing manual snapshots for your DocumentDB cluster. Even after cluster is deleted, manual snapshots are not deleted automatically, and therefore you will incur storage cost on manual backups. Periodically check if the manual snapshots stored are actually required or delete them if they are no longer required. If you see backup cost increase, check your manual snapshots and automated backup retention period to optimize your backup retention period. In summary, unlike on-premise databases or self-managed MongoDB, you can size for sustained load. DocumentDB architecture allows you to scale independent of your data volume, and hence you don't have to provision additional resources upfront. In dev and test environment, determine if you need high availability and higher instances for performance testing. If not, use smaller instances, one or two of them, and also stop them when not used and start when required. For asymmetric workload, create larger instances with more compute capacity to support the queries and stop instances when done. Separate mutable and immutable parts of the documents. That helps not only with performance but also improve cost. By separating mutable and immutable parts of the document, you can save on IOPS cost, as the document size is reduced and updates are made to a smaller document. Using object store like S3 to store files like images, PDF, etc., and DocumentDB for metadata improves your total storage cost. Instead of storing blobs or objects in document store, store them in object store and only metadata store it in DocumentDB. Use appropriate instance size to maintain over 90%, 95% cache hit ratios. Correlate read IOPS to buffer cache hit ratio for monitoring IOPS usage. Using rolling collections or TTL helps avoid IO operation costs due to TTL deletes. Remove unused manual snapshots, as snapshots out of retention period are chargeable. Create billing alerts at 50% and 75% of expected bill. Start with daily tracking, then weekly tracking, and to monthly tracking. DocumentDB per second billing lowers cost for frequent scale up and down use cases and temporary workloads. Using cost allocation tagging can help track expenses at granular level. You can track dev, test, and production clusters and can take actions. That brings us to the end of this session. So before I wrap up, I just wanted to talk about few programs we have. We have a number of programs in place that help us support our customers above and beyond standard documentation, lunch and learn sessions, or specialist essay engagements. We offer a cost analysis tool for generating a DocumentDB sizing and pricing estimate to help our customers understand and estimate the cost. We offer a compatibility tool in our tools GitHub repository that is maintained by our DocumentDB essays. This tool will examine log files and source code to let you know which operators or MongoDB functionality that you are using in your application are currently not compatible with DocumentDB. This helps us to avoid most surprises as we enter into proof of concept or with migration. To help enable customers to build a POC, implement a workload, or generally educate their organization, we offer DocumentDB-centric immersion days led by our DocumentDB specialist essays. With these immersion days, we can provide customizable content based on your areas of interest. We dive deep and offer well-architected reviews to assess customer workloads and focus on optimizing performance, reliability, scale, cost, and operational excellence. We also offer a Springboard program which serves as a customized game plan that begins with decision makers or sponsors and a diverse set of technical and business stakeholders. The output of this half-a-day engagement is an engagement readout that serves as an execution plan. To help accelerate modernization in POCs, we offer data labs. This is a 4-day engagement where AWS provides AWS resources to help customers build tangible deliverables that help accelerate modernization initiatives. Customers walk away with architected DocumentDB prototype with a path to execution. The last area in terms of investments is professional services. We actually have a DocumentDB specialized professional services that is equipped to lead customer through their journey of migration, modernization, as well as accelerate proof of concepts. All right, so with that brings us to the end of this webinar. So in terms of what's next, certainly feel free to scan the Amazon DocumentDB resource QR code. That will take you to our page where you got access to videos and white papers, blogs, all of the resources that you will need to find out more about DocumentDB. And the second QR code is for a DocumentDB landing page for you to get started. And the last QR code is for all our on-demand tech talks. So again, my name is Gururaj Bayari, Specialist Solution Architect on DocumentDB. So thank you for your time and have a great rest of your day.